Hello, 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 and we're back with another edition of your Geometry Flipped Notes. All right, so we've been talking about, the basic figures of geometry in our last unit, and tonight we're going to start embarking on more complicated figures. All right, I can't do that all video. That's going to be crazy. All right, so we talked about polygons and how they're closed figures that are made up of sides and angles. And what we're going to start talking about tonight are the special angles of polygons. So in particular, we're referring to the interior and the exterior angles of polygons. So I've given you a few examples here. You can pick one to draw. And the key is that an interior angle is an angle that's on the inside of a polygon. So that seems like it makes sense. That's made up of any two of the intersecting sides. So this would be an interior angle. So would this one. So would this one. An exterior angle is an angle on the outside of the polygon, but it is specifically created by the extension of any one of those sides. So it's created by one of the existing sides of the polygon and the extension of an intersecting side. The reason that I bring that up is because a lot of times we get confused and we think that if we have a polygon that looks like this, these might be interior angles and this might be an exterior angle, but they're not. When we talk about interior and exterior, we are referring specifically to these types of angles. So this one is not an example. Okay, so what you need to know about these interior and exterior angles are that an interior angle is an angle on the inside of a polygon created by any two adjacent sides of the polygon or intersecting sides. And we talked about an exterior angle. So I'm going to give you guys a minute to go ahead and copy those down. Actually, I'm not going to give you a minute. You guys take a minute by pausing the video and copying these down. And then, okay, we're going to figure out how to find the sum of those angles. So if you recall, the angles of a triangle always sum, I should say the interior angles always sum to equal 180. So if I take any other polygon and I split it into triangles, then in a quadrilateral I create 2, in a pentagon I create 3 triangles, in a hexagon I create 4, in a heptagon I create 5, and in a whatever this is, a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a dodecagon, I create 10. So we always create 2 fewer triangles than we have sides. So exactly like we're saying in a triangle, we create 1 triangle. In a quadrilateral, we create 2, and so on and so forth. So the sum of the interior angles of a polygon, any polygon, is always the number of triangles times 180. Or in other words, the number of sides minus 2 times 180. So this n always stands for the number of sides. 180 being the sum of the interior angles of a triangle, and then this being the number of triangles that we can form within that polygon. So the formula that you need to have memorized that is not on your formula sheet is going to be the number of sides minus 2 times 180, or in other words, the number of triangles we can form times 180. To find one interior angle, and this only works for a regular polygon, we just need to take this formula for the sum and divide it by however many sides and or angles that we have. So that makes sense. Okay, if we have 10 angles and they're all congruent because we have a regular polygon, then to find the measurement of one of those angles, we would just need to divide our sum by 10. The sum of the exterior angles of a polygon is much easier. It's always 360 degrees, no matter how many sides you have. I know that seems crazy, but whether you have a dodecagon or whatever, it's always 360 degrees. And again, if we wanted to find just one exterior angle, again, of a regular polygon only, this will only work if all the angles are congruent, then we're just going to divide the sum of 360 by the number of angles that we have.